Alright guys, I'm going to start from the top. A car company would like to claim that the fuel efficiency on a new line of car it's producing has increased from the 21 miles per gallon which was printed on the sticker from last year's model. Road tests of 44 tanks of gas yielded a sample mean of 23.3 miles per gallon with a standard deviation of 8.8 miles per gallon. Is this sufficient evidence to claim that last year's model has better fuel efficiency than last year? Use an alpha of 5%. Alright. We'll see how this goes. Starting out, first step, state your null and alternative hypothesis. In this case, if there's been no change, then it should be the same as last year's model, which was 21 miles per gallon. And the fact that they want to see if it has increased from last year's model says that if it is not still equal to previous model, it would be bigger than last year's model, or it'd be better miles per gallon, which would imply that it's increased, so you get more miles per gallon of gas. Step 2, we want to find mu x bar, sigma x bar, and the shape of x bar. Excuse me. In general, we know that mu x bar equals to mu, which we are claiming or building as if it was true for miles per gallon of 21. Sigma x bar equals sigma over square root of n. If we do a little sidebar and go over what they've given us, they gave us an n of 44. That's our n. They gave us a sample mean of 23.3. And they have a standard deviation of 8.8. Now, that 8.8 miles per gallon is talking about those 44 tanks. So we know that that is a sample mean, not a population mean. All right, so looking here, we do not have sigma over square root of 44. Can't compute that. So since that's gone, we'll have to go with the next best thing, which is s x bar, which is s over square root of n. So that would be 8.8 over the square root of 44. Which, when I keyed into my calculator, gives me about 1.33 as the standard deviation, or the standard error of x bar. Now, because we have an n that's greater than 30, and because sigma is unknown, and we're dealing with x bar, this would be a student t distribution. Remember our general format for that. So the shape is t equals x bar minus mu over, you can write sx bar, but I'm going to do s over square root of n. It is all in the denominator. So that's approximately a student t distribution. Run that a room a little bit. Degrees of freedom equals to n minus 1, and our n was 44, so our degrees of freedom is 43.